Dear student, today we have a new chapter, chapter 15, whose name is Composition and Resolution of Concurrent Forces. So this composition and resolution of concurrent forces comes in statics group. So in overall, in group B, we have two parts. One is dynamics and another is statics. So this statics group start with this chapter. So here we study the different type of forces. So that is the concurrent forces. Actually concurrent means the forces passing through the same point. एउटै कमन पोइन्टबाट पास हुने सबै फोर्सेसहरू डिफ्रेन्ट फोर्सेसहरू यदि एउटै कमन पोइन्टबाट पास हुन्छ भने दे आर सेड टु बी concurrent forces. So this type of forces we are going to study in this chapter, and again as well even the forces can be resolved into many other forces. एउटा फोर्सेसलाई हामी दुईटा तीनटा डिफ्रेन्ट पार्टमा हामी रिजल्भ गर्न सक्छौं, त्यसलाई ब्रेक डाउन गर्न सक्छौं र तिनै फोर्सेसहरूलाई कम्पोजिसन, फोर्सको कम्पोजिसन भनेको we can express the sum of all forces into the equivalent forces. र एउटा कुनै फोर्स सर्टन फोर्सलाई अथवा त्यसको रिजल्टेन्टलाई हामी डिफ्रेन्ट भेक्टरहरुमा फोर्सहरुको अल्जेब्रिक सममा चाहिँ एक्सप्रेस गर्न सक्छौं. So in this way we can study the composition and resolution of concurrent forces. Now today we study about resultant of forces and its direction. So let's see, here we have two forces. So one of the forces is Q forces, this is Q forces, and another forces is P forces, this is P forces. We have two forces acting at O. यदि कुनै दुईटा फोर्सेसहरु एउटै पोइन्टमा यसरी एक्ट भएको छ भने the angle between them is alpha. So alpha be the angle between them. That means two forces, P forces and force P and force Q, whose directions are given as figure, given in figure. And the R be the resultant of these forces. So R be the resultant of these two forces which act at same point 0, which can resolve the two forces making an angle theta. Theta जसले theta angle बनाउँछ with forces P. Force P सँग यसले theta angle बनाउँछ. Similarly, P force and Q force को resultant is the R vector, R forces or force R. So let's see, let's write down what will happen if two forces P and Q, two forces they acting at a point O, and alpha be the angle between them, then the resultant R, then resultant R vector or R we can write down, resultant R, force R, resultant R is given by R square is equal to P square plus Q square plus 2PQ cos alpha. So this is the formula to find the resultant of two forces, which can be written as like this. Square हटाउँदा हामी यसलाई root underमा पनि लेख्न सक्छौं यसरी, P square plus Q square plus 2PQ cos alpha. So this is the formula to find the resultant of any two forces making an angle theta with force P. So According in the adjoining figure, we can see that we have two forces whose resultant is R, which makes angle theta with force P, and as a whole alpha is the angle between P force and Q force. So R be the resultant or resolution of two forces, which can be expressed in the form of this one. R square is equal to P square plus Q square plus 2PQ cos alpha, which is also written as R is equal to root under taking square root of this whole term. So this is the formula of resultant. And similarly, tan theta is equal to Q sin alpha divided by P plus Q cos alpha. So this is another formula which gives the direction of resultant R. So from this formula, we can find out the resultant force of any two forces, and from this formula we can find out the direction of that resultant. So in this formula we apply Q sin alpha divided by P plus Q cos alpha. So by using this formula we can find out the direction, in which direction it acts or force acts we can find out, and this is the formula to find the resultant. So in this way, any two forces when combined with making an angle alpha, then R will be the resultant of them. So in this chapter we can describe the different type of forces. Concurrent force means these two forces acting at the same point. That's why these two forces are known as concurrent forces, and we can find the resultant and direction of that resultant by using this formula. So with the help of this formula we can do or we can solve the many questions in the exercises. So this is the question based on this resolution of the forces. If we have two forces and their resultant R, then we can find out the value of R with the help of these two forces P, Q and alpha as well. So we have the value of P, this is force P, that's why it is in Newton. This is another force Q, 7 Newton. Alpha, it is the angle between them. So alpha is equal to 90 degree. So with the help of this find R. So we are going to find out the value of R by using formula. So we know that we can use the formula of R. R is equal to root under P square plus Q square plus 2PQ cos alpha. So this is the formula to find the resultant of two forces P and Q. So let's substitute the value of P, Q and alpha according to the question. So P means it is 24, so it is 24 square. Q square means it is 7 go square. And 2 times P means 24, it is 24. Q is 7 and cos alpha means it is 90. So after solving this one, we get cos 90 means it is 0, so all the values are 0 over here. And here 24 square plus 7 square plus it is 0. Cos 90 means 0, so it becomes all the elements 0. And after substitute this by squaring of them, we get the certain value. Then we are going to expand this one. 24 square means 576 plus 7 square means it is 49. So altogether we have root under 625. When addition of these two numbers, so it will give the 25. So therefore resultant R is equal to 25 Newton. So this is the required solution of resultant. If two forces are given, P and Q, and alpha is given, then we can find out the resultant of these two forces by using this formula. So you have to remember this formula for resultant. So in this way we can solve it. Now we have these questions. So two forces P and 2P. So in the instead of P and Q, here is P and 2P. P र Q force भने जस्तै यहाँ P र 2P force छ, acting at the same point O or something, have the resultant this one. This is R. यो PQ force को resultant हामीसँग छ, यहाँ छ √3P is the resultant. So find the angle. Angle is going to find. So it is not given. So find the angle between the two given forces. So angle between two forces is always denoted by alpha. So we are going to find the value of alpha. At what angle these two forces are acting at the same point. So this is the question. So for this we can do forces P. We have two forces P and 2P. So and the resultant is this one. So हाम्रो क्वेशनमा चाहिँ P को ठाउँमा P नै छ, Q को ठाउँमा 2P छ र R को ठाउँमा के छ √3P छ. And alpha is equal to what? So angle between two forces is alpha. So with the help of this information, we can find out the value of alpha by using appropriate or suitable formula, which is the formula of resultant. Now we can use the formula. Using formula to find the resultant. R is equal to, or R square, we can write down the R square. R square राख्दाखेरि root राख्नु पर्दैन. R square is equal to P square plus Q square plus 2PQ cos alpha. So this one is the formula to find the resultant. यदि यहाँ square राख्ने हो भने root under राख्नु पर्दैन. Then R square is given by √3P को whole square. This is the value of resultant which is given √3 times P, and P square it is same as previous. P means P, and the value of Q is 2P. So write down 2P square. So 2 and P force भनेको P force, Q force भनेको 2P force and cos alpha. So after substituting we get this term. So now we can expand this one. √3P square means it is 3P square, and it is P square, and 2P whole square means it is 4P square. 2 to the 4, again 4P square and cos alpha. Now all the P square we can transpose into another side. So it is 5P square. 3P square minus 5P square means minus 2P square, and again we have cos alpha. This is same as it is. Write down P square cut down, and 4 and 2 also again cut down. So 2 times, that means minus 1 by 2 is equal to cos alpha, and we can write down cos alpha is equal to, it is cos alpha is equal to cos 120 degree. It is the value of cos 120 degree. So by comparing both sides, alpha is equal to 120 degree. So this is the required angle between two forces P and 2P. So with the help of this formula, by applying this formula and substituting the forces and this resultant value, we can deduce this term into 120 degree, which is the angle between them. So in this question, angle is to be asked, at what angle do forces equal to P plus Q newtons and P minus Q newtons act so that the resultant may be this one. So as the previous question, we have P plus Q newton. One of the force is given, which is P plus Q, and another force is P minus Q newton, and their resultant is this one, root under P square plus Q square. Now we have to find out the value of alpha, which is angle. So let's find the angle by using the formula of resultant of two forces. दुईटा force को resultant को formula use गरियो भने angle automatic आउँछ. So let's use this formula. Now we can solve it by taking this data, so force P is equal to here P plus Q Newton, it is Newton, N means here Newton, and Q force is P minus Q Newton, and the resultant is capital R is equal to root under P square plus Q square Newton. This is also Newton, this is also Newton. All are the forces, so write down the Newton everywhere, and alpha is equal to what? So we are going to find this angle, so angle is represented by alpha. So we know that R is equal to, or R square is equal to P square plus Q square plus 2PQ cos alpha. So this one is the formula of resultant. So substituting the value, so R को square, यो टर्म चाहिँ स्क्वायर मा गयो, root under P square plus Q square को whole square, this is R, and make it square according to the formula. So P square means this term to the power 2, so that means P plus Q को whole square, and the Q, another force is P minus Q whole square, and 2 is same, P means it is P plus Q, and P minus Q, PQ, and cos alpha is same, it is cos alpha, it is same as above. So after substituting we get this term, so this one is the expression, and if we solve it then we get P square plus Q square, square root and square, we can cancel each other. So after using formula we get P square plus 2PQ plus Q square plus, so this one is the formula, P square minus 2PQ plus Q square plus 2P plus Q, P minus Q means it is P square minus Q square cos alpha. So after this term we have this one, P square plus 2PQ Q square, this is the formula of A plus B whole square. Here is A minus B whole square, so this will be the formula of A minus B whole square. So A plus B, A minus B means we can directly write as A square minus B square means P square minus Q square, cos alpha is same and 2 is same. So we can cancel P square, Q square as well in this way. So 2PQ again we can cancel. So the term remaining over here is P square, Q square. So let's write down this one, P square, Q square लाई उतापट्टि लैजाउँ, minus P square minus Q square is equal to 2 times P square minus Q square cos alpha. This is the remaining term after cancelling all the term, and this divide this गर्दा के आउँछ यहाँ minus common लिन सकिन्छ, P square plus Q square divided by 2 times P square minus Q square is equal to cos alpha. So यो यस्ता alpha निकाल्नु पर्ने भएको हुनाले make it separate or be isolated. So this goes to the denominator, this will be the denominator of this term. So we are going to find angle only, not cos alpha, only alpha. So alpha should be isolated, alpha be separated. So therefore alpha is equal to minus P square plus Q square divided by P square minus Q square times 2. Again we have 2. Alpha means cos inverse, it will be cos inverse minus this one, 2 is also over here, minus 1 by 2 P square Q square. So this is the answer. So cos alpha बाट alpha मात्र हामी सेपरेट गर्न सक्छौं, alpha सेपरेट गर्यो भने cos लाई यता ल्याउँदा it will be cos inverse, and here is minus 1 by 2, so write down minus 1 by 2, and this upon this means it is the angle, required angle is this one. So we can arrange the term to find the alpha from here. So in this way, by using this resultant formula we can find out the appropriate angle for this condition. So we have this question now. So in question, two forces of magnitude 3p and 2p respectively. We have two forces. One of the force is 3p, another one is 2p respectively. Have a resultant R. The दुईटा force को resultant R छ हामीसँग. If the first force be doubled, this is the condition. यदि हामीले पहिलो फोर्सलाई डबल गर्यौं भने the magnitude of the resultant will be doubled. यसको रिजल्टेन्ट को म्याग्निट्युड पनि रिजल्टेन्ट को भ्यालु पनि के हुन्छ इज डबल हुन्छ भने फाइन्ड द एंगल बिट्विन द फोर्सेस. सो इन दैट कंडिशन what is the value of angle we are going to find. So this is our question. So we can interpret or write down the question in this form. So we have the formula of resultant is this. So r square is equal to p square. First force को square means we have 3p. p को ठाउँमा हामीसँग 3p छ. So write down 3p square plus q square भनेको q को ठाउँमा हामीसँग 2p छ. So 2p square plus 2 into p into q. p भनेको 3p हो. So 3p and q भनेको it is 2p and cos alpha. So alpha be the angle between them, these two forces. So this is the result or resultant of these two forces after substituting the main formula. So if you solve it, then we get 9p square plus 4p square, 6 to 12p square cos alpha. So if you solve it together like term 9 to 4 13, 13p square plus 12p square and cos alpha. So it is equation 1. So this is the equation 1 from this condition. Yeah, actually this is r square is equal to p square plus q square plus 2pq cos alpha. So this is the main formula which can be written as like this, and from this we can deduce this equation by arranging the like term together. So also, so by question, look at here, first force be doubled. पहिलो फोर्सलाई हामी डबल गर्छौं. फर्स्ट फोर्स इज दिस वन. यसलाई हामी डबल गर्छौं इन्टु 2 गर्छौं भनेको 3p इन्टु 2. यसलाई फर्स्ट फोर्सलाई हामीले डबल गर्नु पर्यो यो अकॉर्डिङ टु दिस कन्डिसन. बट सेकेन्ड फोर्स इज नट म्यानिपुलेटेड. यो फर्स्ट सेकेन्ड फोर्सलाई यहाँ केही भनेको छैन. देयर इज नो इन्फर्मेसन अबाउट द सेकेन्ड फोर्स. So it remains constant, it remains same. So write down the resultant will be double. The resultant is double also. So पहिलाको resultant r छ भने it will be double by multiplying this one. So it will be 2r. अब हाम्रो 2r हुन्छ. पहिला r छ भने now it will be 2r. 2r whole square is equal to 3p. 3p लाई अब 3p into 2 के लेख्नु पर्यो 6p लेख्नु पर्यो. 6p को square and another force is same 2p square and 2 times p भनेको अब यहाँ 6p, त्यसपछि अर्को भनेको 2p and cos alpha. यस्तो हुन्छ. हाम्रो फर्मुला अनुसार हाम्रो यो रिजल्टेन्ट फर्स्ट फोर्स लाई चेन्ज गर्यो भने we can find out this value. So after substituting or this making square, removing this square bracket, we get 36p square, 4p square, 2 6 are 12 to 24 p square cos alpha. So now we can add 4r square is equal to 36 and 4 means it is 40p square 24p square cos alpha, equation 2. So this one is the equation 1 and this will be the equation 2. Now we can solve this equation and this equation altogether. So अब हामी चाहिँ यो r square को भ्यालु हामी इक्वेसन 1 बाट यहाँ युज गर्न सक्छौं. So using 1 we get, so solving 1 and 2 we get, now we can write down solving 1 and 2. So it will be 4 is same but r square is this one. So write down the value of r square 13p square plus 12p square plus 12p square cos alpha. It is cos alpha is equal to 40p square plus 24p square cos alpha. यो r स्क्वायर को ठाउँमा मैले माथिको इक्वेसन 1 युज गरेँ 13p square 12p square cos alpha and another term remains same. Now multiplying this one 13 4s are 52 52p square 4 12s are 48 48p square cos alpha and this is 40p square plus 24p square cos alpha. So cos alpha लाई एक साइडमा लाने p square लाई एक साइडमा लाने. So 40 यता ल्याएर माइनस गर्दा कति हुन्छ 12 हुन्छ 12p square 48 लाई उता लग्यो भने कति हुन्छ 24 minus 48. So 8 minus 4 2 4 minus 2 2 minus 22p square cos alpha. यस्तो फर्म आउँछ. So we can cut down p square and p square and 12 and 22 मा 2 6 जा 2 11 जा 2 6 जा 2 11 जा. So cos alpha is equal to this one 6 by 11. 8 minus 4 4 4 minus 2 2. 4 it is 4 not 2 it is 4 and 12 2 ja. So it is 12 2 times 12 2 ja 24 and then it will be cos alpha is equal to minus 1 by 2. Therefore alpha is equal to 120 is the required answer. So this is the required answer obtaining from this one. So minus 2 लाई त लाँदा we get minus 1 by 2 हुन्छ. So minus 1 by 2 is the value of cos 120 degree. So alpha is equal to 120 degree. So in this way you can solve this problem. So first of all form the equation 1 and 2. Then put the value of r square in equation 2. Then after solving we get cos alpha is equal to minus 1 by 2 which is this one. Alpha is 120 is the required angle between these two forces. Now we have this question. The resultant of two forces P and Q acting at an angle alpha is equal to 2m plus 1 times root under P square plus Q square. So this is resultant. Resultant is this one. Resultant is given and we have two forces P and Q and the alpha is the angle between them. So this is one of the information. And this is the first case. So from first case we can deduce, we can make or we can form one equation. And similarly after then when they act at an angle 90 minus alpha, if the angle between these two forces is 90 minus alpha, then the resultant will be this one. Resultant will be slightly changes with minus sign. And in this both cases we can find out, deduce the term tan alpha is equal to m minus 1 by m plus 1. So we can solve it by different two cases. So from two cases we can deduce the two equations. So make two equations and we can solve them and finally we reach at this conclusion. So let's see, resultant is this one. So we have resultant is this one. Actually resultant is this. So write down 2m plus 1 root under P square plus Q square. So this is the resultant. So make it whole square. This is r square. This is a resultant and it is P square plus Q square plus 2pq cos and angle between them is alpha which is given here. This is alpha. Two forces P and Q. Two forces P and Q are same but resultant is different in our equation. हाम्रो इक्वेसन अनुसार हाम्रो रिजल्ट अथवा फर्मुला अनुसार it is r square P square Q square 2pq cos alpha. So this one is the answer. So after squaring we get 2m plus 1 को whole square and P square plus Q square. यहाँबाट root n square we get P square plus Q square and this p square plus q square पनि यतै ल्याउँ minus times p square plus q square plus is equal to 2pq cos alpha. So this term goes to this here in this side, and now we can take common. This and this is common. So take out the common, p square plus q square. It is common. So write down or also even. So it is 2m plus 1 whole square minus 1. So 2m plus 1 whole square minus 1 is the term remaining here. So here is 1, here is this term. We have taken out p square plus q square as a common, and here is 2pq cos alpha. So we can cut down this formula after expanding a plus b whole square. So write down p square plus q square into 4m square plus 2ab means 4m, and plus 1 minus 1 cancelled. b square गर्दा 1 square 1 हुन्छ, 1 1 cancel. So it is 2pq cos alpha. So it is equation 1. So in this way we can find out the equation 1 after deducing this term. Now let's use the second condition where angle is 90 minus alpha and the resultant is this one. So these two terms are different here. So also resultant is this one, 2m minus 1 root under p square plus q square r square by r square is equal to 2pq. So forces are same. So write down p square plus q square plus 2pq cos alpha. Alpha को ठाउँमा हाम्रो एंगल कति छ 90 minus alpha छ. So write down 90 minus alpha. So this is r square, this is p square plus q square plus 2pq cos alpha. Alpha को ठाउँमा 90 minus alpha, resultant को ठाउँमा the new value or given provided value चाहिँ यहाँ राख्नु पर्यो. So after solving, so removing curly bracket, then we get 2m minus 1 को whole square and here p square plus q square is equal to, here is p square plus q square 2pq cos 90 minus alpha means it is sin alpha. Now we can this term, यो दुईटा टर्मलाई हामी अझै अहिलेको जस्तै यता ल्याउन सक्छौं. यहाँको जस्तै यता ल्याएर we can take out the common. यो टर्म र यो टर्म कमन आउँछ, यसलाई यतापट्टि ल्याएर कमन लिन सकिन्छ. So after taking common we get the same term, p square plus q square, it is common, and 4m square plus 4m, that is same term. So we get p square plus q square, and here is 4m square plus 4m after solving this question, sin alpha equation 2. So here is the steps is not appeared here. So if you take out this common here, we can take out the common p square plus q square. Then remaining term means this square means 1, this minus 1 as previous step. So if you expand this one, a minus b whole square, this one minus 4m. So if here is minus, then write down minus over here. It is minus because a minus b whole square, here is minus sign. So we can deduce this one. Now we can divide this equation by 1. Equation 2 divided by equation 1. Then only we can show this result. So let's see the another result. So in this question, we are just now derive this term equation 1 and equation 2. हामीले भर्खरै equation 1 र 2 निकाल्यौं. So we can see that this is equation 1 which have this term, and we have this term in equation 2. So to deduce this condition tan alpha is equal to m minus 1 upon m plus 1, we can divide it both side because tan alpha means sin alpha by cos alpha. You divide यो गर्ने बित्तिकै tan alpha आउने भएको हुनाले we have to divide it. So dividing equation 2 by equation 1. Here 2pq sine alpha divided by 2pq cos alpha. So here this divided by this, that means RHS divided by RHS is equal to LHS divided by LHS. So write down the LHS, p square plus q square into 4m square minus 4m divided by here p square plus q square times 4m square plus 4m. So this one is the result after dividing equation 2 by equation 1. So we get this term. Now we can cut down this and this. And here we can cut down this and this. And if you take common 4m from here, then it will also cancel. So let's write it is tan alpha. So tan alpha. Here we can take out common 4m. So it is m minus 1. And here is also 4m. So it is m plus 1. So 4m we can cancel. And we get tan alpha is equal to m minus 1 divided by m plus 1, which is our required result. So here is the result. So hence we can prove the result tan alpha is equal to m minus 1 by m plus 1. So this is the solving process. So first of all, use resultant formula r square is equal to p square plus q square plus 2pq cos alpha. Then after if we use this information in the formula, then we get these two type of equation. So after dividing it, we get the required result. अब हामीसँग छ resolution of forces. एउटा कुनै सिंगल फोर्सलाई हामी दुईटा कम्पोनेन्टमा रिजल्भ गर्छौं, दुईटा कम्पोनेन्टमा ब्रेक डाउन गर्छौं, x कम्पोनेन्ट y कम्पोनेन्टको फर्ममा along x axis along y axis को फर्ममा कुनै एउटा फोर्सलाई हामीले रिजल्भ गरेपछि त्यसमा कस्तो सिचुएसन आउँछ, कस्तो कन्डिसन आउँछ, the forces will be at what condition the forces will be in this case. So resolve into the forces, त्यसलाई ब्रेक डाउन गर्ने फोर्सहरु कस्तो हुन्छ हामी गर्दै छौं. So we have one of the forces, so it is r force, it is force r. हामीसँग एउटा फोर्स r भन्ने चाहिँ एउटा सर्टेन पोइन्ट o मा छ र यो फोर्सलाई हामी दुईटा कम्पोनेन्टमा ब्रेक डाउन गर्छौं. एउटा फोर्सलाई x एक्सिसमा राख्छौं, दिस इज x एक्सिस, र एउटा फोर्स भनेको हाम्रो p फोर्स हुन्छ, यस्तो हुन्छ, and it is horizontal component or x component or horizontal component making an angle alpha. यो एंगल अल्फा भयो, अल्फा एंगलमा हाम्रो डिस्क्राइब गरेका छौं यहाँ. त्यस्तै अर्को यो यसको अर्को y कम्पोनेन्ट वाला फोर्स चाहिँ y एक्सिसमा पर्ने गरी, यसरी y एक्सिसमा पर्ने गरी, इट इज y एक्सिस. एन्ड नेक्स्ट फोर्स इज q फोर्स. यहाँ q फोर्स छ, p फोर्स q फोर्स चाहिँ हाम्रो दुईटा कम्पोनेन्टमा ब्रेक भएको छ, मेकिङ एन एंगल बीटा विथ y एक्सिस. दिस रिजल्टेन्ट फोर्स is vertical component of this resultant is q force making an angle beta, and the force p is the horizontal component of this resultant making an angle alpha. So in this way we can resolve the single force r into two components in two ways, along x-axis and along y-axis. So in this case we can find out the force P and force Q with the help of R. So what is the formula? Let's see. Here is let R force B given force which is to be resolved along OX and OY making angles OX मा alpha छ and OY मा beta छ. So this is equation respectively. So this is respectively. So we have R force and it is going to resolve along OX and OY, making angle alpha and beta respectively. If P force and Q force be two components of R vector along P vector लाई OX मा राख्ने and Q vector लाई OY मा राख्ने, then we can find out the force P and Q like this. So force Q is equal to, the value of Q is obtained by R sin Q को लागि हामी यो एंगल लिन्छौं sin alpha divided by sin alpha plus beta. So this is the formula to find the force Q with the help of resultant and with angles. And force P is found out by R sin beta. So P को लागि हामी यो एंगल लिन्छौं, Q को लागि opposite angle, P को लागि यो opposite angle R sin beta and sin alpha plus beta. So this is the denominator is same over here, this one and this one, and Q को लागि alpha र P को लागि beta. Q को लागि this angle, P को लागि this angle. यसरी लिएपछि we can find out Q and P from two resolution of forces. एउटा फोर्स को रिजोल्युसन दुईटा पार्टमा रिजल्भ गर्दाको कन्डिसन फोर्सहरु with the help of resultant निकाल्न सकिन्छ. So this is the formula to find the resolved part of any forces. So in this way we can use the formula. So this formula will be helpful to solve the question in the problem. Now we find the resultant of any number of coplanar forces acting at a point. एउटा certain point मा act गरिएका different forcesहरु जुन एउटै plane मा पर्छ. Coplanar means the forces lying on same plane. So these are known as coplanar forces. एउटै plane मा पर्ने यस्ता forceहरु different number of coplanar forcesहरुको resultant how to find, कसरी resultant निकाल्ने भन्ने कुरा हामी यहाँ स्टडी गर्छौं. So let's see, we have one of the resultant at a point. हामीसँग एउटा x axis मा, this is x axis and this is y axis, this is y axis, this is origin, र हामीसँग कुनै एउटा resultant छ. Suppose this is the resultant R, this is R, resultant forces which act at O. एउटा forces छ resultant force जुन acting at O मा act भएको छ, जसले x axis सँग बनाएको छ एंगल थीटा एंगल बनाएको छ भने अब यो फोर्सलाई हामीले डिफरेंट नम्बरमा हामीले रिजर्भ गर्न सक्छौं with horizontal component, horizontal line and vertical line. R को horizontal component R cos theta हुन्छ, R को vertical component R sin theta हुन्छ. र हामीले यदि डिफरेंट फोर्सहरुलाई चाहिँ रिजर्भ गर्यौं, सपोज हामीसँग P1 भन्ने फोर्स छ मेकिङ एंगल अल्फा 1 छ, अर्को P2 भन्ने फोर्स छ, यहाँ P2 भन्ने फोर्स छ मेकिङ एंगल अल्फा 2 भन्दियौ, अर्को फोर्स यतापटि छ, यस्ता फोर्स धेरै हुन सक्छन्, P3 छ मेकिङ एन एंगल विथ x एक्सिस अल्फा 3 हुन सक्छ. So in this way we can resolve many forces in the same plane. र यस्तो केसमा यो P1 cos theta, P2 cos theta, cos alpha 1, P1 cos alpha 1, P2 cos alpha 2, P3 cos alpha 3 को अल्जेब्रिक सम तिनीहरुलाई जोड्दै जाँदा जुन एउटा कम्पोनेन्ट आउँछ त्यसलाई x मान्यो भने र P1 sin alpha 1, P2 sin alpha 2, P3 sin alpha 3 गर्दा भर्टिकल कम्पोनेन्ट आउँछ र त्यो सबै भर्टिकल कम्पोनेन्टहरुको अल्जेब्रिक समलाई हामी यहाँ y भन्छौं र सबै होरिजोन्टल कम्पोनेन्टहरुको समलाई हामीले यहाँ x भनेर सपोज गर्छौं. त्यतिबेला r भनेको रूट अन्डर x स्क्वायर प्लस y स्क्वायर हुन्छ. So in this way one resultant forces can be resolved into many coplanar, many forces which is shown at here. अब हामी यसलाई देखाउन गइरहेका छौं. So let's write, if x and y be sum of resolved parts of the forces along two mutually perpendicular lines, then resultant force R is given by R is equal to root under x square plus y square. So this is the formula of resultant force, and tan theta is equal to y divided by x. So this implies that theta is equal to tan inverse y by x. So this is y. Theta is equal to tan inverse y by x, where theta is the angle made by resultant with x-axis भनेको OX. One note is, if x is equal to 0 and y is equal to 0, then forces are in equilibrium. So this is the note, special note regarding to resultant of different forces. So as you see that in the figure, so x and y be the sum of resolved part of the forces along two mutually perpendicular lines. This is OX and OY are mutually perpendicular. They are at right angle. They are the axis, x-axis and y-axis, as you know that. And x भनेको हाम्रो कम्पोनेन्ट, होरिजेन्टल कम्पोनेन्टहरुको एउटा फोर्सहरुको एउटा सम हो भने भर्टिकल कम्पोनेन्टहरुको समलाई हामीले y मानेका छौं, र यो गर्दाखेरि x र y को हेल्पबाट रिजल्टेन्ट r कसरी निकाल्ने भन्दा r इक्वल टु रुट अन्डर x स्क्वायर प्लस y स्क्वायर. सबै होरिजेन्टल कम्पोनेन्टहरुको स्क्वायर प्लस भर्टिकल कम्पोनेन्टहरुको स्क्वायर, समको स्क्वायरलाई रुट अन्डर गर्ने बित्तिकै we can find out the value of r. And it gives the magnitude of all forces. यसले magnitude दिन्छ, कुनै एउटा नम्बर दिन्छ. It gives the numerical measurement of resultant, and tan theta gives the direction of the resultant. So it gives resultant by measuring the theta angle. Tan theta is equal to y upon x. So in this way we can find out theta. Theta is equal to tan inverse y upon x. This is similar result which can be deduced from here. And theta is the angle made by resultant. This resultant ले OX अथवा x axis मा बनाएको angle चाहिँ theta हो. So theta is the angle made by resultant with x axis or OX. So in this condition, when x is equal to 0 and y is equal to 0, then all forces are in equilibrium. Equilibrium condition मा balance condition मा बस्नको लागि x 0 र y 0 हुनुपर्छ. At that case resultant becomes 0. यसलाई रिजर्भ गर्न सकिन्न, ठिक्क ब्यालेन्स हुन्छ, वेल कन्डिसनमा बस्छ. सो सबै 0 भएपछि हामीले रिजल्भ गर्नु पर्दैन. इट इज equilibrium condition. So for equilibrium we should have x is equal to 0 and y is equal to 0. So in this way we can resolve one of the resultant force with horizontal component and vertical component, making different angle alpha 1, alpha 2, alpha 3 like that. So sum of algebraic sum of all resolved forces in the horizontal component is x, and algebraic sum of all vertical component of the forces is y. So by using x and y we can find out the resultant, and which gives the direction by using this formula. And these two formula we have to keep in mind. Mind मा हामीले राख्नुपर्ने formula यो दुईटा हो, which is also used in exercise. एक्सर्साइजमा पनि यो फर्मुला युज हुन्छ र यसलाई चाहिँ हामी राम्रोसँग ध्यान दियौँ. सो इन दिस क्वेसन we have to resolve a force which is 50 न्युटन. यो आर भन्ने फोर्सलाई हामीले दुईटा पार्टमा रिजल्भ गर्नुपर्छ. दुईटा फोर्समा जुन दुईटा फोर्सले 60 डिग्री र 45 डिग्रीको एंगल बनाउँछ. सो जस्ट भर्खरै हामीले पढेको एउटा कुनै फोर्सलाई we can resolve into two parts or many forces with the help of this alpha and beta. So this is the angle alpha is equal to 60 degree and beta is equal to 45 degree. We can suppose it this one, and this is resolve this force. र यो फोर्सलाई रिजल्भ गर्नुपर्ने फोर्सलाई हामी आर भन्छौँ. अलवेज रिजल्भ गर्नुपर्ने फोर्सलाई क्यापिटल आर. 50 न्युटन फोर्स is going to resolved by using formula this one. So we have, so this is the formula. P is equal to Q sine beta. Q, no, it is R. R sine beta divided by sine alpha plus beta. So this is the formula to find P. P सँग हाम्रो बीटा आउँछ, Q सँग अल्फा आउँछ. ट्याक्कै उल्टो जस्तै आउँछ. So R sine beta divided by sine alpha plus beta. So substituting all the value, we get the value of P. So R is equal to 50 and sine beta, beta means 45 degree, and here is sine alpha plus beta means it is 60 plus 45. So find out the value. 50 and sine 45 means 1 upon root 2. So this is the value of sine 45 and sine 60 plus 45. So it is 105, but we don't have the exact value of sine 105 by using trigonometric table. So we can use compound angle, sine A cos B plus cos A sine B. So from here we get root 3 plus 1 divided by 2 root 2. So this is the final answer after using compound angle formula. Sine A plus B को formula sine A cos B plus cos A sine B. तो formula use गरेर value substitute गर्दा final answer, our final answer will be root 3 plus 1 by 2 root 2. यो form हुन्छ. And finally we can solve it by solve गर्दै जाँदा हामी के पाउँछौं? Solve गर्दै जाँदा 50 root 2 cancel, root 2 cancel. So 2 माथि जाँदा 100 upon root 3 plus 1. 2 माथि गयो 100 upon root 3 plus 1. This one. Okay. Now 100 root 3 plus 1 ले अब cross multiply गरे पनि हुन्छ. Here 100 upon root 3 plus 1 multiply by root 3 minus 1 divided by root 3 minus 1. So we can use conjugate over here to simplify it. So this is A plus B, this is A minus B. So it will be A square minus B square, and 100 divided by root 3 minus 1 is same, and here is root 3 square means 3, 1 square means 1. So it is 2. र 2 ले 100 लाई काट्दा कति हुन्छ? 50 हुन्छ. 50 root under root 3 minus 1. So this is the answer of P. P को भ्यालु हामी यसरी निकाल्न सक्छौं, and Q को भ्यालु पनि यसै गरी निकालौं. Q is equal to R sin alpha divided by sin alpha plus beta. So this is another formula to find the force Q. So let's write the value of R. It is 50 and sin alpha means it is 60 divided by, here is also sin 60 plus 45. And if you write down the value, sin 60 means root 3 by 2. It is root 3 by 2, the value of sin 60, tabulated value. And sin A plus B, sin A cos B plus cos A sin B. So if you use this formula, we get root 3 plus 1 divided by 2 root 2 again, 105. This is also 105. So it is root 3 plus 1 by 2 root 2. So 2 we can cancel, एन्ड √2 माथि गयो भने के हुन्छ √2 माथि गयो भने √6 √3 र √2 √6 भयो 2 3 जा 6 सो 50 √6 भयो 50 √6 बाई √3 प्लस 1 यस्तो भयो यसलाई पनि हामीले अझै कन्जुगेट लाएर सल्भ गर्न सक्छौं so if you make it conjugate -1 and √3 -1 then this will be 50 √6 √3 -1 divided by a square minus b square so it is 2 3 square minus 1 square means 2 2 ले 50 लाई काट्न सक्छौं 2 and 20 50 गर्दा 25 √6 √3 -1 so in this way we can find out the answer so one of the answer is this one another answer is this one so we can resolve this resultant force into two forces P and Q like this so use the formula of this one and calculate the value according to the our provided information so this one is the resultant resolving force according to the resultant so here we have this question forces 1 Newton 2 Newton and 3 Newton act at a point एउटा पोइन्टमा एक्ट भएको तीनवटा फोर्सहरु छ in the direction parallel to the side of the equilateral triangle equilateral triangle को साइड सँग प्यारलल हुने गरी तीनवटा फोर्सहरु एक्ट भएको छ भनेको यो तीनवटा फोर्सहरु मिलाएर हामीले इक्विलाटरल ट्रायंगल बनाउन सक्छौं सबै साइड सँग प्यारलल हुने गरी taken in order so find their resultant now we are going to find the resultant now let's see so our solution is so three forces so one of the force is here at point O so one force is 1 Newton another force is 2 Newton in order another force is 3 Newton in order so these are the three forces 1 Newton 2 Newton 3 Newton acting at a point एउटा पोइन्टमा एक्ट भएको छ र यो तीनवटा फोर्सलाई हामीले तीनवटा फोर्ससँग प्यारलल हुने गरी एउटा हामी इक्विलाटरल ट्रायंगल बनाउँछौं इक्विलाटरल ट्रायंगल बनाउँदै छौं यहाँ ट्रायंगलको साइडसँग प्यारलल हुन्छ सो राइट डाउन दिस ट्रायंगल ड्रा दिस ट्रायंगल so this is A B and C ABC so here यो 1 Newton force लाई यो साइड सँग यो साइड प्यारलल हुन्छ so write down this arrow this side parallel to this side so parallel side this is 1 Newton write down here त्यस्तै 2 Newton भनेको यो साइड अब 2 Newton BC is parallel to O something this force is यो फोर्स सँग यो फोर्स हाम्रो इक्वल छ BC साइड प्यारलल छ यो सँग यो र त्यस्तै यो साइड भनेको हाम्रो यो साइड चाहिँ हाम्रो के छ 3 न्यूटन छ 3 न्यूटन this side is parallel to this side so all forces acting at a same point here also all forces acting at a same side same point जस्तै यसमा पनि हाम्रो सबै फोर्सहरु एउटै उसमा चाहिँ एउटै पोइन्टमा एक्ट भएको छ कसरी भने पोइन्ट हामीले यसलाई मानौं यो OX भने जस्तै हाम्रो x एक्सिस भने जस्तै AB is taken as x axis AB लाई हामीले x एक्सिस मान्यो भने यो फोर्स चाहिँ यो पोइन्टमा एक्ट भयो त्यसपछि यो फोर्स भनेको हामीले यसलाई यसरी लेख्न सक्छौं यो फोर्स सँग यो फोर्स प्यारलल हुन्छ हैन यो फोर्स र यो फोर्स सेम हो znači यो फोर्स पनि यही पोइन्टमा एक्ट भएको छ त्यस्तै यो फोर्सलाई हामीले प्रोड्युस गर्यो भने यो फोर्स सँग यो फोर्स एक्ट भएको छ यो फोर्स एक्ट भएको छ so this force and this force acting at a same point A एउटै पोइन्ट A मा एक्ट भएको छ के जुन पोइन्ट यो लाइनलाई प्रोड्युस गरेर बनेको लाइन हो this is the same force we can extend it we can proceed it and this side is also parallel to this side यो साइड केही फरक छैन सो यो तीनवटा फोर्सलाई हामी यसरी रिजल्भ गर्न सक्छौं एउटै पोइन्टमा यसरी र यसरी ब्रेक डाउन यो जसरी हामी रिजल्भ गर्न सक्छौं सो यो वेबाट हामीले अब एङ्गलहरू निकाल्न सक्छौँ एङ्गल निकालेर हेरौँ र धेरै तीनवटा फोर्सहरूलाई रिजर्भ गर्दै जाँदा हाम्रो एक्स र वाई कस्तो आउँछ फर्स्ट अफ अल रिजल्टेन्टको लागि एक्स र वाई चाहिन्छ क्यापिटल एक्स एन्ड क्यापिटल वाई बिकज द फर्मुला अफ रिजल्टेन्ट इज रुट अन्डर एक्स स्क्वायर प्लस वाई स्क्वायर सो वाट इज एक्स एन्ड वाट इज वाई सो लेट्स राइट सो रिजल्भिङ along all forces resolving all forces along and perpendicular AB को अलोङमा सबै फोर्सहरूलाई हामीले रिजर्भ गरौँ र पर्पेन्डिकुलर AB सँग पर्पेन्डिकुलर हुने लाइनसँग पनि त्यसलाई रिजल्भ गर्न सक्छौँ यसो गर्दाखेरि क्यापिटल एक्स इज रिटन एज क्यापिटल एक्सलाई हामी अब ब्रेक डाउन गर्न सक्छौँ क्यापिटल एक्स भनेको सबै होरिजेन्टल कम्पोनेन्टहरूको सम इट इज द अल्जेब्रिक सम अफ all components so x मा के आउँछ भने फोर्स इन्टु एङ्गल फोर्स इन्टु एङ्गल फोर्स इन्टु एङ्गल हामीसँग 1 न्युटन छ पहिलो फोर्स सो राइट डाउन 1 इन्टु अब यसमा होरिजेन्टल कम्पोनेन्ट cos अल्फा आउँछ cos alpha so alpha is what is the angle of this force with x axis यो एक्सिस ले AB ले x axis सँग कति डिग्रीको एंगल बनाउँछ भन्दा 0 डिग्रीको एंगल बनाउँछ so write down 0 cos 0 because it is also this force is also taken as the x axis AB मै हामीले फोर्स लाई रिजल्भ गरेको हुनाले it is 0 and another force is 2 into cos अब यो फोर्स भनेको यो फोर्स हो र यो फोर्समा कति डिग्रीको एंगल बनाएको छ यो लाइनले अथवा यो फोर्सले एक्स एक्सिस सँग बनाएको एंगल कति हो त्यो चाहिँ हाम्रो फाइन्ड गर्नु पर्यो सो यो एंगल र यो एंगल प्लस गर्नु पर्यो दुईटा प्लस गर्दा कति डिग्रीको एंगल बन्छ तो वी क्यान फाइन्ड आउट कति बन्छ त भन्दा यो दिस इज इक्विलैटरल ट्रायंगल एज यू नो दैट दिस इज इक्विलैटरल ट्रायंगल सो दिस एंगल इज 60 degree and this angle is also 60 degree 60 plus 60 means it is 120 हाम्रो टोटल एंगल चाहिँ हाम्रो यहाँदेखि यहाँसम्म चाहिँ 120 डिग्री छ है यो 120 डिग्री छ सो राइट डाउन 120 डिग्री प्लस एन्ड 3 न्यूटन means it is what अब हाम्रो यहाँ यो पोइन्ट देखि यहाँसम्मको एंगल लिनु पर्यो यो पोइन्ट देखि यहाँसम्मको एंगल लिनु पर्यो सो this is 180 straight line भनेको this becomes 180 plus 60 means it is 240 degree so this is the total angle by this line with x-axis in anti-clockwise direction so in this way we can interpret or write down the value of angle 240 degree with x-axis AB मा हेर्नु पर्यो एंगल चाहिँ हाम्रो अलवेज AB मा हेर्नु पर्छ र यो लाइनलाई प्रोड्युस गर्दा बनेको एंगल टोटल एंगल चाहिँ यहाँ लेख्नु cos alpha को ठाउँमा एंगल मेड बाय दिस फोर्स विथ एक्स एक्सिस अथवा OX अथवा AB here is AB यो फर्ममा मिलाएर लेख्ने so we can write down 1 into cos 0 means it is 1 and 2 into cos 120 means it is minus 1 by 2 2 into cancel and 3 into cos 240 means it is also minus 1 by 2 because it is 180 plus 60 means cos 60 and but it is minus cos 60 and cos 60 means 1 by 2 and minus means minus so it lies in third quadrant and in third quadrant cos is negative so minus 1 by 2 is the answer of value of this cos 240 so when you solve it then we get 1 and 1 cancelled and minus 3 by 2 is the result part of x मा आउने भ्यालु भनेको हाम्रो minus 3 by 2 हो so similarly we can find out the value of y x र y अब हाम्रो यहाँ भर्टिकल कम्पोनेन्ट को फर्महरु आउँछ यो माथिको जस्तै सेम हो 1 हुन्छ तर cos को ठाउँमा अब यहाँ sin आउँछ भर्टिकल कम्पोनेन्ट भएपछि sin आउँछ एंगल आर सेम 2 into sin 120 3 into sin 240 यस्तो हुन्छ र हाम्रो भ्यालुहरु फाइन्ड आउट गर्दै जाउँ यहाँ चाहिँ कति हुन्छ भ्यालु so it is 1 into sin 0 means 0 sin 120 means the value of sin 60. Sin 60 भनेदेखि √3/2, 2 to cancel, and 3 into sin 240. So sin 240 means 180 plus 60, that is minus √3/2. So if you solve it, then we get this is 0 and √3 minus 3 √3. Rather minus 2 √3 and 2 काट्दाखेरि के आउँछ minus √3/2. √3 plus 2 √3 minus 3 √3 means minus √3/2. Yes, it is the correct answer. Y is minus √3/2. Now we can find out the resultant. X square plus y square. Square root of this is the resultant. So this one is the formula. So substituting the value of x value minus 3 upon 2 whole square, and the value of y is minus √3/2 square. So after solving it, 9/4, 3/4, and 12/4 means 3, and √3. 12 minus 4, 12, 9 plus 3, 12. 12/4 means 4 3s are 12. So √3 is the correct answer. This is resultant. And the tan theta. And tan theta is equal to what? Y divided by x. And here is y minus √3/2. And value of x is minus 3/2, 2 to cancel, and minus minus also cancel. √3/3 means 1 upon √3, and the value of theta is, therefore theta is equal to 180 plus 30 degree. So this is the value. This is 210. So angle made by resultant with x-axis is 210 degree. So here we have written 180 plus theta. किन 180 plus theta लेखेको भने किनकि x पनि नेगेटिभ, y पनि नेगेटिभ छ. x र y दुवै नेगेटिभ भएपछि it lies in third quadrant, and third quadrant भनेको 180 plus theta हो. So 180 plus लेख्नै पर्छ. थीटा भनेको हाम्रो मिनिमम एंगल अफ 1 upon √3. 1 upon √3 भनेको 30 को भ्यालु हो tan मा. So 180 plus 30 means 210. So in this way we can find out the resultant and direction of this resultant. So angle made by, find their resultant only. So it is also direction. Now we have Lemi's theorem. So this theorem is very important theorem. So what does Lemi's theorem say? Look at here. So write the statement of Lemi's theorem. So we are going to state and prove the Lemi's theorem. Lemi's theorem ला हामी स्टेटमेन्ट गर्दै जान लाग्छौं, स्टेट र प्रुफ पनि गर्न लागेका छौं. So let's see what will be the Lemi's theorem. So if three forces, write down, if three forces acting at a point be in equilibrium, then each of the force is proportional to the sine of the angle between other two. यो स्टेटमेन्टले के भन्छ भने यदि हामीसँग तीनवटा फोर्स एउटै पोइन्टमा एक्ट गर्छ भने तीनवटै फोर्स इक्विलिब्रियम कन्डिसनमा हुनु पर्यो. दैट इज द कन्डिसन. तीनटै फोर्स इक्विलिब्रियममा छ भने, एउटै पोइन्टमा एक्ट भइरहेको छ भने हरेक फोर्सहरु त्यसको साइन अफ अपोजिट एंगल, त्यसको अरु दुईटा एंगलको बीचको साइन अफ दैट एंगल सँग प्रोपोर्शनल हुन्छ. भनेर यो स्टेटमेन्टले भन्छ. So this says the Lewis theorem. That means in figure we can interpret is like this. So if this is force P acting at O and same force is applied here, another force Q, same force, and another force is R force. Three forces are acting at a point O. O भन्ने पोइन्टमा एक्ट गरेको छ, and if they are equilibrium condition, equilibrium बराबर फोर्सले यसलाई चाहिँ पुल आउट गरेको छ, पुल गरेको छ भने यो पी फोर्स भनेको यसको यो भनेको यो केसँग अपन हुन्छ भने यसको अपोजिट एंगलसँग, यसको अपोजिट एंगल पी को लागि अपोजिट एंगल यो हो भनेको साइन अफ क्यू कमा आर, क्यू र आर को बीचको एंगल चाहिँ साइन अफ दैट एंगलसँग प्रोपोर्शनल हुन्छ भने जस्तै क्यू फोर्स साइन अफ दिस एंगल पी र आर फोर्स को एंगलसँग प्रोपोर्शनल हुन्छ. सिमिलरली आर फोर्स क्यू र पी को एंगलसँग साइन अफ दैट एंगलसँग प्रोपोर्शनल हुन्छ भनेर यो स्टेटमेन्टले भन्छ. सो नाउ वी आर गोइङ टु प्रुभ दिस वान. कसरी हुन्छ भनेर अब हामी प्रुभ गर्न गइरहेका छौं. सो लेट्स प्रुभ. नाउ लेट P force, Q force, R force be three forces acting at O, be in equilibrium, इक्विलिब्रियममा छ. यदि हामीसँग तीनवटा फोर्स, थ्री फोर्सेस भनेको छ, दैट इज P, Q and R acting at a same point which are in equilibrium, then we can write यस्तो छ भने सो यो तीनवटा फोर्सको सम अफ all forces is equal to 0. इक्विलिब्रियम छ भने त्यसको रिजल्ट जहिले पनि 0 हुनुपर्छ. रिजल्टेन्ट अफ all three forces becomes 0. नाउ यसमा चाहिँ अब पी भेक्टरले पी फोर्सले क्रस प्रोडक्ट गर्ने. नाउ पी क्रस पी प्लस क्यू प्लस आर, पी ले हामीले दुवैतिर के गर्ने पी फोर्सले मल्टिप्लाई गर्ने. दिस इज 0. पी फोर्सले मल्टिप्लाई गर्ने, यता पनि मल्टिप्लाई गर्ने, पी फोर्सले दुवैतिर मल्टिप्लाई गर्ने. सो 0 इन्टु पी फोर्स. So P force दुवैतिर मल्टिप्लाई गर्ने. And now P force into P force, force P and force Q, force P and force R is equal to 0. Then it will be 0 and P cross Q minus R cross P हुन्छ. यो उल्टो हुन्छ. R लाई यता P लाई उता गर्दा अर्डरमा लेख्ने. P पछि Q, Q पछि R भएको हुनाले आर पछि फेरि पी आउँछ, आर पहिला लेखेर पी पछि र यसलाई चाहिँ यस्तो लेख्ने. अब पी क्रस क्यू इज इक्वल टु आर क्रस पी भनेर लेख्ने. यो फर्मलाई उता लाने बित्तिकै इट विल बी पोजिटिभ. पी क्रस क्यू इज इक्वल टु आर क्रस पी. एन्ड वी क्यान टेक आउट द मोडुलस. पी क्रस क्यू इज इक्वल टु टेकिङ मोडुलस आर क्रस पी. सो we can write down like this, modulus taking modulus on both side भनेर हामी भन्छौं र यसको क्रस प्रोडक्टको फर्मुला हामीले अप्लाई गरिरहेका छौं. यदि यो p + q + r 0 हुन्छ भने हामीले टेकिङ क्रस प्रोडक्ट विथ p भनेर लेखेका छौं. दुवैतिर p भेक्टरको क्रस प्रोडक्टले मल्टिप्लाई गरेको. अनि के यो क्रस प्रोडक्टमा के हुन्छ भने सेम भेक्टर क्रस सेम भेक्टर इज अलवेज 0 हुन्छ. सो applying this rule in this step we can write down 0 and p cross r लाई r cross p बनाउँदा it will be minus and minus बाट लाँदा plus. सो अब यहाँबाट मोडुलस हाम्रो p cross q क्रस प्रोडक्ट अफ टु भेक्टरको हाम्रो फर्मुला लाउँदा p into q into sin p comma q यस्तो हुन्छ. this is modulus p, this is modulus q, means magnitude of q, sign of angle between them. This is the definition of cross product. Definition of cross product. Magnitude of P, magnitude of Q, and sign of angle between them. Similarly, magnitude of R, magnitude of P, and sign of r comma p sin of their angle between r and p r र p छ भने त्यसैको बीचको एंगल हामीले लिनुपर्छ त्यो पनि साइनमा क्रस प्रोडक्टबाट जहिले पनि साइन आउँछ सो इफ यु डिवाइड इट बाइ pqr pqr ले हामीले यसलाई चाहिँ डिवाइड गर्यौं भने हामी चाहिँ pq pq काटिन्छ r अपन के हुन्छ sin p q हुन्छ इज इक्वल टु pqr pq rp काट्दाखेरि हाम्रो q आउँछ यहाँ चाहिँ यहाँ q आउँछ q डिवाइड बाइ sin r p हुन्छ this is equation 1 so in this way we can find the equation 1 from here so pq र rp छ यहाँ pqr ले डिवाइड र यहाँ pqr ले डिवाइड गरौँ अथवा यसलाई अपन मा लैजाउँ माथि pqr लेखौँ त्यसो गर्दा pq pq काटिन्छ r आउँछ r अपन यो भयो अनि pqr तल जाँदा p र r काटिन्छ q रहन्छ q अपन यो अपन q अथवा q अपन यो that is same thing so r अपन pq हुन्छ r को मुनि p र q को बीचको एंगल आउँछ q को मुनि sin r र p को बीचको एंगल आउँछ q हुँदा r र p आउँछ र r हुँदा यो r हुँदा p र q आउँछ यतापट्टि p र q आउँछ सो अल्टरनेट आउँछ र यसले भन्न खोजेको नि त्यही हो साइन अफ द एंगल बिट्विन अदर टु रिमेनिङ एंगल भनेको हो यसरी आउँछ सो इन द सेम वे वी क्यान टेकिङ क्रस प्रोडक्ट नाउ विथ q जसरी हामीले p ले क्रस प्रोडक्ट गर्यौं त्यसरी नै q ले क्रस प्रोडक्ट गर्ने अब चाहिँ अबको स्टेपमा फोर्स q ले हामी क्रस प्रोडक्ट गर्छौं सो लेट्स सी व्हाट विल ह्यापन now this is the equation 1 same equation 1 equation a भन्नु यसलाई equation a let's see this is equation 1 no problem pqr यो equation a मा फेरि again taking cross product with q vector q force or vector so from a भन्नु it is from a this equation now cross product of q cross p plus q plus r force is equal to 0 into q भेक्टरले दुवैतिर क्रस प्रोडक्ट गरेको अघिको स्टेप जस्तै हामीले क्रस प्रोडक्ट q ले क्रस प्रोडक्ट गरिरहेका छौं इक्वेसन a मा सो इफ यु मल्टिप्लाई दिस one q cross p plus q cross q plus q cross r is equal to 0 and q cross p लाई हामी p cross q बनाऊ p cross q बनाऊ this is minus and it is 0 and q cross r यो हाम्रो अर्डरमा भएको हुनाले p पछि q पछि r भएको हुनाले p पछि q लेख्ने p पछि q लेख्दा जस्ट अपोजिट गर्दा it will be minus so change into minus and q cross r is equal to plus p cross q यो माइनस उता जाँदा प्लस हुन्छ p vector cross q vector or p force cross q force so it is cross product multiplying vectorically भन्ने concept हो यो and if we put modulus over here then it will be like this so we can take this modulus on both side taking modulus on both side गर्दा we get q into r into sin q र r को बीचको एंगल आउँछ अब q र r को बीचको एंगल यानी p र q गर्यो भने p into q into sin p र q को बीचको एंगल आउँछ where p q and r are the magnitude of p vector q vector and r vector or p force q force and r force is also vector so it is similar and sign of angle between them p र q कै बीचको एंगल आउँछ त्यसले p र q लेखेको अब pqr ले डिवाइड गर्यो भने qr कट हुन्छ p अपन के हुन्छ यहाँ sin qr हुन्छ इज इक्वल टु pqr से pq गयो r अपन हुन्छ अब यहाँ r अपन sin p अपन q हुन्छ इक्वेसन 2 सो combining 1 and 2 combining equation 1 and 2 we get p upon sin q upon r q comma r q upon sin r comma p and r upon sin p upon q so this is Lami's theorem hence Lami's theorem is proved so in this way you force p force q र force r को तल जहिले पनि p छ भने qr आउँछ क्यू छ भने रिमेनिङ पिक्युआरमा रिमेनिङ आरपी आउँछ, आर छ भने पिक्युआरमा पिक्यु आउँछ। सो दिएको फोर्स भन्दा तल चाहिँ साइन अफ एंगल बिट्विन अदर टू आउँछ जहिले पनि। सो दिस इज द लेमिस थियरम एन्ड इन दिस वे लेमिस थियरम इज proved, or we can verify the Lemis theorem, which is very important for exam also. So let's solve or let's prove this theorem like this. Here we have this question now. Forces P, Q and R. Three forces are here which are acting along OA, OB and OC. OA भन्ने साइडमा हाम्रो फोर्स P राख्नु पर्यो and force Q चाहिँ OB मा एक्ट गरिरहेछ, force R चाहिँ OC मा। Where O is the circumcenter of the triangle. Triangle को बाहिर सर्कल हुनु पर्यो अथवा सर्कल को भित्र ट्रायंगल हुनु पर्यो। So circumcenter of the triangle ABC, circumscribing the triangle भन्छ यो केसमा। सर्कल भित्र हामीसँग ट्रायंगल छ जसको सेन्टर O छ। are in equilibrium. They all are in equilibrium position. Are in equilibrium. So यदि तीनवटा फोर्स इक्विलिब्रियममा छ भने we can use Lemis theorem. Lemis theorem एक कन्डिसनमा लाउने हो। यदि तीनवटा फोर्स छ एउटै पोइन्टमा एक्ट भएको छ र इक्विलिब्रियममा छ भने Lemis theorem can be applied. So here, so using this Lemis theorem, prove that P upon A cos A is equal to Q upon B cos B is equal to R upon C cos C. So this can be proved by using Lemis theorem when they are in equilibrium. So let's prove number 1. First number हामीले prove गर्दैछौं। So let's draw the picture. So this is center O, and one of the triangle is drawn over here. So this is triangle and this is center O. So this is A, this is B, this is C. So OA भनेको P force, OB भनेको Q force, and त्यसपछि यो force भनेको R force. P, Q, R. Three forces are here acting at point O, where O is the circumcenter. Center को यो सर्कल को सेन्टर हो, O त सर्कल को सेन्टर हो र PQR एउटै तीनवटै फोर्स एउटै सेन्टरमा एक्ट भएको छ, एउटै पोइन्टमा एक्ट भएको छ भने यो सर्कल को लागि यो ट्रायंगल को लागि चाहिँ P upon A cos A, Q upon B cos B, R upon C cos B हुन्छ भनेर प्रुभ गर्नु पर्यो। So in figure we have sin A is equal to यो P force, हाम्रो यो एंगल को जस्ट हाफ हुन्छ, यो एंगल को हाफ हुन्छ, यो भनेको sin A भनेको 2BOC, हाफ अफ BOC, अथवा BOC भनेको हाफ अफ sin A. So we can write down here by using it is inscribed angle. This is inscribed angle, this is central angle, and we know that relation between inscribed angle and central angle is always half of the inscribed angle. So BOC is equal to 2 times of A. BOC, angle BOC is equal to 2 times of A. यो A भन्ने एंगल को BAC 2 times of BAC भने पनि हुन्छ। BAC means it is 2A. Same thing. BOC, this angle भनेको A को just double हुन्छ। Central angle is always double of the inscribed angle. In this way, central angle is twice the inscribed angle standing on same arc BC, same arc भनौं न, अहिले same arc भनौं। सेन्ट्रल एंगल जहिले पनि यदि एउटै आर्कमा स्ट्यान्ड छ भने सेन्ट्रल एंगल जहिले पनि इन्स्क्राइब्ड एंगल को डबल हुन्छ। यो इन्स्क्राइब्ड एंगल हो, this angle is inscribed angle, and this is central angle। जहिले पनि एउटै आर्क भनेको BC आर्कमा हाम्रो चाहिँ दुईटै एंगलहरु BC आर्कमा छ, सेम आर्कमा छ. So in this way you can write down this one. Similarly, angle ABC, angle BOC है, BOC त्यो भयो. अब एंगल AOC भन्नु अब यहाँ एंगल AOC is equal to 2 times of B हुन्छ. एंगल त्यस्तै AOB, एंगल AOB भनेको 2 times of C हुन्छ. यो फिगरमा हामीले हेर्यौं भने AOC भनेको तपाईको एंगल, यो एंगल यसको डबल B को डबल हुन्छ. त्यस्तै AOB यो एंगल C को डबल हुन्छ. यसरी हामी लेख्न सक्छौं. So now we can use all the regions are same region, and by using Lemmy's theorem, Lemmy's theorem use गर्दा के हुन्छ हाम्रो P force divided by sin of opposite angle भन्छौं हामी. अब यदि P force हामीले लिएको छौं भने यसको अपोजिट एंगल भनेको यो एंगल BOC. अब के हुन्छ यहाँ sin angle BOC हुन्छ. यसरी लेख्ने P upon sin of the angle between other two. अरु दुईटा फोर्स को बीचको एंगल हामीले लेख्नु पर्छ. P फोर्स माथि लागेको छ भने एंगल तलको लेख्नु पर्छ B र C, अथवा Q र R फोर्स को बीचको एंगल लेख्नु पर्छ. त्यस्तै Q फोर्स लियो भने sin of angle Q फोर्स यहाँ छ भने यसको अपोजिट एंगल यो हो AOC को एंगल लेख्नु पर्छ. यो एंगल Q फोर्स को अपोजिट अनि हाम्रो AOC हुन्छ. त्यस्तै R फोर्स भनेको यो फोर्स, यसको अपोजिट फोर्स भनेको AOB. हामी चाहिँ sin of angle AOC यस्तो हुन्छ. यो थियरम हो Lemmy's theorem. Now we can substitute the value of this one. Sin BOC भनेको 2a, यहाँ 2a लेखौं माथिको रिजनबाट, and Q upon AOC भनेको 2b, यहाँ sin 2b लेखौं, and R upon AOC भने AOB, not AOC, it is AOB, R को यतापट्टि AOB, it is AOB. So sin AOB means it is sin 2c. So this is the result by using this value, and we know that sin 2a means 2 sin A cos A. This is trigonometric relation. 2 sin B cos B is equal to R upon 2 sin C cos C. So this is the formula of this one. And our proof is A cos A, cos A, cos B, cos C. Here is cos A, cos B, cos C. We can write down these 2 cancel, 2 cancel, and P upon sin A भनेको A by 2R लेख्ने, and Q upon sin B भनेको B by 2R cos B, and R by sin C भनेको C by 2R into cos C. And this is obtained by sine law from trigonometry. So from trigonometry we can write down sin A is equal to A by 2R, or small a is equal to 2R sin A. This is the trigonometry which is known as sine law in trigonometry. Sine law भन्छ यसलाई. sin को भ्यालु A by 2R, sin B को भ्यालु B by 2R, sin C को भ्यालु C by 2R. यो 2R कट भयो भने we get therefore P by A cos A. So P by A cos A is equal to Q by B cos B is equal to R by C cos C. So hence proved. So in this way we can prove the result from this way. यो वेबाट हामी चाहिँ यसलाई प्रुभ गर्न सक्छौं. त्यही भएर चाहिँ Lemmy's theorem युज गर्ने, त्यसमा एंगलको भ्यालु सर्टकटमा राख्ने AOC 2b, AOB means 2c, and sin 2a लाई 2 sin A cos A, 2 sin B cos B, 2 sin C cos C राखेर sin A को ठाउँमा A by 2R, B by 2R, C by 2R राख्दै जाने. We can use sine law over here. Now cos A, cos B, cos C, we don't use any rule because cos A, cos B, cos C is in problem. हाम्रो प्रुफ दैटमा cos A cos B cos C सेम छ यसलाई सेम छोड्ने बाकी चाहिँ sin लाई कन्भर्ट गर्ने sin ल लाउने we can deduce the condition like this. So this is the way of solving or a way of proving this result. Now we are going to prove equation this number 2 लाई अब हामी यो प्रुभ गर्दैछौँ हामी एकछिनमा this one. So let's see how can we solve it. We can prove it. So from the similar process also we can show this result. Just now we have proved this result, and on the similar process also we can show this relation, and the process are same. So it is number 2 question, and the figure is same, and we can use the same theorem by Lemmy's theorem. So from the figure by Lemmy's theorem, just now we have proved P upon A cos A, Q upon A cos B, and R upon A cos C. हामीले भर्खरै हामीले लास्टमा सेकेन्ड लास्ट पोजिसनमा यो रिजल्ट प्रुभ गरेका थियौं A cos A, A cos B, A cos C. एक्चुअली यहाँ आउँछ sin 2A, sin 2B, sin 2C, र sin 2A लाई 2 sin A cos A, 2 sin B cos B, 2 sin C cos C गरेका थियौं भर्खरै, र 2 क्यान्सल हुन्छ, sin A को ठाउँमा A by 2R, sin B को ठाउँमा यहाँ B हो, B by 2R, sin C को ठाउँमा यहाँ C हो, C by 2R आउँछ, र यो वेबाट हामी A cos A, B cos B, C cos C लेख्न सक्छौं. अब यसपछि फर्दर 2 स्टेपमा हामी यो देखाउन सक्छौं. सो राइट डाउन A भनेको अब हाम्रो यो हुन्छ, A भनेको ABC cos the value of this A छँदैछ, A को A छ cos A को भ्यालु चाहिँ B square plus C square minus A square divided by 2BC हुन्छ. So this is the cosine law. B को B cos B भनेको अब हाम्रो के हुन्छ, C square plus A square minus B square divided by 2CA हुन्छ. It's equal to R upon C. Cos C भनेको हाम्रो के हुन्छ, A square plus B square minus C square divided by 2AB यस्तो हुन्छ. So cos A को भ्यालु यो हो, cos B को भ्यालु this one, the value of cos C is this one. So in our result मा cos A cos B cos C छैन. That means we have to remove this term cos A cos B cos C हटाउनु पर्छ यहाँबाट, र यहाँबाट हटाउँदा हामी यो फर्मुला युज गर्न सक्छौं. This is cosine law from trigonometry. Trigonometry मा हामीले यो cosine law already पढिसकेका छौं. So we have already learnt in trigonometry, and this is cosine law. So we can remove cos A cos B cos C by using cosine law over here. So A, B, C remains same, and now here A लाई A ले multiply गर्ने, A square B square plus C square minus A square divided by 2ABC गर्ने. यहाँ पनि एउटा A, यहाँ पनि एउटा A ले multiply र divide गर्ने सँगसँगै A थप दिने यसमा र यसमा. Similarly Q upon यसमा B square थप दिने, अब C square plus A square minus B square divided by 2ABC, and R upon C square A square plus B square minus C square divided by 2ABC. यसमा C ले मल्टिप्लाई गरे मैले, यसमा B र B ले मल्टिप्लाई र डिवाइड, यसमा C र C ले मल्टिप्लाई र डिवाइड. यसो गर्दाखेरि हाम्रो यो 2ABC we can cancel the same ratio in each proportion, and then we have A square times B square plus C square minus A square, Q upon B square C square plus A square minus B square, and R upon C square times A square plus B square minus C square. Hence proved. So यो क्वेशनमा हामी सेकेन्ड नम्बरको प्रुभ गर्नको लागि सेम फर्स्ट नम्बरको रिजल्टबाट अगाडि बढ्छौं. हाम्रो फर्स्ट नम्बरको रिजल्ट छ P upon A cos A, Q upon B cos B, R upon C cos C. यो फर्स्टकै रिजल्टबाट हामी अगाडि बढ्छौँ र यो रिजल्टमा कस ए कस बी कस सीको कोसाइन लको भ्यालु यसरी डिड्युस गर्यो भने युज गर्दाखेरि हामी चाहिँ हाम्रो रिजल्ट अर्को नेक्स्ट रिजल्ट चाहिँ हामी निकाल्न सक्छौँ। सो ट्रिग्नोमेट्रिक रिलेसनहरू लाएर र मेन इम्पोर्टेन्ट थिङ्स इज लेमिज थियरम युज गरेर हामी यो डिफ्रेन्ट कन्डिसनहरू प्रुभ गर्न सक्छौँ। सो दिस इज द वे अफ सल्भिङ दिस क्वेसन by using Lemi's theorem. So all the students, so remember the Lemi's theorem and write down the properties of trigonometry. Just now you can see you have to know about the sine law, cosine law from trigonometry and use that formula, and finally we get the required condition.